So yeah, this is one type of 3D printer. It's probably the type you see very often. It relies on this process called FDM, which is fused deposition modeling. And this is a really kind of gimmicky thing on Wikipedia. But basically what you have is you have a nozzle. Think of it kind of like a stack of pancakes. The 3D printer, what it'll do is it'll make the first pancake on the bottom, and then after that, the platform will actually separate a little bit. And then it'll make another pancake, and it does that over and over again. So basically you have a really big stack of pancakes. and yeah, so this is made by a company called MakerBot. I bought it back in 2012. It's an older 3D printer, but it still works pretty well. I believe they already have one generation ahead already, which it's really cool, but I've heard that it breaks down a lot, so that's another thing. When it comes to hobby 3D printing, the industry loves to talk about how, oh, it's ready for the masses, anyone can buy one now. That's bullshit. Excuse me, for my language. They break down a lot. I have to say, in terms of how often I get a print that I like, it's probably 1 out of every 4 I print, because they're notorious for breaking down. It's not just me. Just go on any 3D printing forum, and they're going to tell you that it has this problem. Question?
Yeah, just real quick. Is it similar to this fiberglassing machinery, where you constantly have to keep it clean? Plastic buildup, is that a problem? I guess.
Yeah, well, that's a good question. Oftentimes, a 3D printer will stop working, and you really won't know why. A problem that I deal with a lot is that the actual nozzle will get clogged up with plastic over time. And what I'll do is I'll disassemble the heat extruder, this whole thing, basically get a blowtorch, and I'll get the nozzle, and I'll just light it up till it's glowing red hot. Then I'll dip it in alcohol, and I'll do that process over and over again to clean out the inside, because that does happen. You'll get a buildup of plastic on the inside. Right now, my printer, it's having this one problem where whenever I'm printing a big part, or even a small part now, there'll be times where it's called an air print, where basically they'll keep on extruding plastic, they'll keep on, this is plastic filament. It's called PLA, polylactic acid. This is one type of plastic you can use. You can use ABS, that's the stuff Legos are made of, nylon, and there's many different plastics you can use on a 3D printer. But what will happen is it'll be feeding in the plastic through the top, and basically there's a little drive gear. That's basically the drive gear is forcing this plastic into the nozzle. Yeah, it's I guess you'd say plastic injection, not completely, because basically it's just extruding a really thin layer. Whereas plastic injection molding, you'll have a part, the plates, they just inject the plastic and you come out, you got yourself your part. So it takes a little bit longer, but yeah, no, what will happen now is that for some reason my drive gear, it'll jam because it's pulling on the filament, but it just doesn't have the torque necessary to pull on the filament whenever it's on the spool, because this is usually, it's sold on a spool of plastic, and it's sold by kilogram usually. So 1 kilogram, if you buy it from the MakerBot people, they'll rip you off and they'll sell it to you for $48. If you go on Amazon and just type in PLA 1 kilogram, you can find it for $20. And if you have Amazon Prime, you get free shipping. That's what I do. So yeah, what I'm gonna move on to now is I want us to make something on Solidworks right now, and I was thinking of something we could do in under an hour, and I was fishing around my desk and I saw this wrench, and I was like, this would be perfect. So what we're gonna do is we're gonna design this on Solidworks, and then afterwards we're gonna export it to the 3D printer and we're gonna print it. So that's gonna show you more or less how a 3D printer can be useful. Okay, so I guess we'll get started. Okay, so this is a simple computer-aided drawing software. It's called SolidWorks. There's other ones. There's by Autodesk. There's AutoCAD, Inventor, even Google Sketch. There's a lot of free ones as well. I was trained on SolidWorks. Actually, I was originally trained on AutoCAD back in high school, but I stopped using AutoCAD for 4 or 5 years, and I completely forgot how to use it. So I'm using SolidWorks now because I'm more proficient in SolidWorks. So what we'll start here is anything like, I like to say that anything that you see in life is basically can be broken down into simple shapes. Like you see this, and you're like, okay, I see a circle here, I see a circle here, I see a rectangle. So that's how we're going to start designing this on SolidWorks. So I'll look at this end, and this is, according to my caliper, it's about 16.5 inches. Millimeters. 16.5 millimeters. And then on the other side, we're looking at something like maybe 21. So we'll make it 17 and then 21. Oh, and another thing, we want the distance in between. So we have 2 circles and a rectangle. The rectangle is about 70 millimeters in length. The big circle is 21 millimeters in diameter, and the small circle is 17. So start off with would be, you'll sketch. You can choose different kinds of planes. Usually I like to start in the top plane. So I'll put in a circle. Here are little basic shapes that you can have, like a rectangle, a line, circle, a spline. You got an arc here, an ellipse, polygon, a bunch of different stuff. So basically we start off with one circle there, and we want it to be 21? Yeah, I was like 21 millimeters. So I'll type in 21 there. Okay, so that circle has a diameter of 21 millimeters. From one circle to the next, we said it was about 70 millimeters. So you put in, what I'm doing right here is I'm basically making just any line, and then I'll click on this. It's called Smart Dimension. You click on the object that you want to change its length or its diameter or its size, and it'll let you modify right there. So that line right now, it's 52 millimeters. I'm changing it to 71, so it extends outwards. And then we'll have another circle right here, and that one, we said it was 17 millimeters in diameter. So bam. Okay. Now we have ourselves 2 circles and a line. Okay. What next? Well, this actually has has a width. It's not just a simple line. It's a rectangle in a way. So what I'll do, I'm really lazy on SolidWorks, so I like to take a lot of shortcuts. Instead of making another 2 lines here, what I'll do is I'll click on this feature. It's called offset. You'll see this in pretty much all CAD software. What it does is you click on it, and it allows you to click any line, circle, triangle, and basically when you click on it, this number, it offsets that distance. So if I click on this line, it wants to offset it by 10 millimeters downwards. I can modify that. Same thing goes if I click on a circle, for example. It wants to offset that circle an additional 10 millimeters from the original point. So it makes life easier, whenever you want to, instead of having to draw another circle or another line. So this has about a width of, it's 9 millimeters. So instead of offsetting it twice, what I'll do is I'll click on this other feature that's called bidirectional. So what that does for you is it basically offsets in both directions. So we want a rectangle with a width of 9. So half of 9 would be 4.5. So basically it's offsetting right now 4.5 in that direction, 4.5 in this direction. Okay. So now we got ourselves a circle and a bunch of other lines right there. What we want to do now is we want to clean it up because there's a bunch of stuff here that we want to get out of the way. Another feature that's really prominent in a lot of CAD softwares is called trim. So I usually by default have it on power trim. I don't know if AutoCAD has power trim, but I know SolidWorks does. So what I'll do now is I'll get close to the circle here. I'll be like trim, trim, trim. Trim, trim, trim. Then over here, let's trim here, trim here, trim here, and trim here. And we'll also trim over here. Okay, so now it's starting to look like, it's starting to get there, okay? Little by little, we're making ourselves this wrench. Next, what I'll do is, on this end of the wrench, I see a hexagon. So I'll use the polygon feature here on SolidWorks, which is right here. And it lets me draw any kind of polygon. I can draw a pentagon, I can draw a hexagon, I think it's called a septagon, and then an octagon, and so on and so on. So it's already, a hexagon has 6 sides, you know, it's already there by default. What we want to know is we want to know more or less what the diameter on the inside of this hexagon is. So we measure from one side of the hexagon to the other. It looks like it's 10 millimeters, so we have to come there. Okay, so, well, actually, I think it's going to be less. I think I misread it. I think it's actually 7. Oh no, I'm right. My bad. It is 10. Okay, so right there, basically this number right here, it gives you a circle on the inside of whatever polygon you're making. Whether it's a hexagon, an octagon, like the circle is making contact with some of the edges. So we just saw that it's more or less like a 10 millimeter diameter circle on the inside of that hexagon. So just type in 10 right there, enter, and so that's smaller than I thought I was going to. Okay, well that's good for us. Okay, so now we have that one end of the wrench that you know, is meant to for the nut. What we'll do now is we'll continue on this side to design this feature right here. Now, like I look at this and I think that maybe this point right here could be considered the center of that circle that we made, like right there in the center. So what I'll do is I'll actually, or oh no, actually no. First, what I would do is I look at this wrench, and from one side of the wrench to the other, I can say that's kind of like a straight line. But if you notice right here on the actual wrench that makes contact with the nut, it's kind of angled slightly. So you know, you'll look at this and you'll be like, okay, I have this wrench right here, and I have this angle right here. So I think that's like kind of like maybe like a 10-degree angle. Like this is how like I would design this. There's other ways. There's multiple ways to design something on SolidWorks or on AutoCAD. I'm just showing you how like my mind would think when I'm designing this wrench. So I'd be like, okay, I want something like a 10-degree difference versus a straight line. So what I'll do is I'll create, and I started that line at the center of that circle because that's more or less the reference point I'm using for this right here. So I drew a straight line here, and then now I'll get another line here, and I'll go like this, just out there. I don't know what angle that is, but what I do know is this is a 180-degree angled line, a straight line. So I click using the Smart Dimension feature again, this line and then this line, and I find out like the angle right there. And I already said I wanted like a 10-degree angle, so I type in 10 degrees right there. Okay. Now, what I have is, I want to know more or less what this like distance is, and I think it's 10, right? That's what we found out last time. Yeah, it's about 10. So I'll use that offset feature we used before again, and I'll click. I deselected chain, that way it only selects the line. If you click on chain, it'll actually like want to select a lot more. So I click on this, and basically it offsets like that. It offsets, you know, oh no, wait, we wanted this to offset. Instead of 9, we wanted 5, because 10 divided by 2 would be 5 millimeters. So it's basically offsetting 5 millimeters up, 5 millimeters down, based on that line I found earlier that was basically 10 degrees off the horizon. Okay.
You guys thought he was just going to print a gun. You didn't know there was going to be math, right?
Yeah, so they actually took those down, but if you still want to find those files, you can get them on Pirate Bay. So yeah.
America.
So yeah, then basically what I'll do is I'll make another little circle on the inside right there and connect these 2 lines. Now I have a bunch of clutter again. So what I'm gonna do is I'm gonna use a trim feature to start trimming all this extra stuff off. And now it's actually starting to look somewhat like a wrench. So really, wrench. So I wanted to make it look a little bit more pretty, and wrenches don't usually look this way. So what I'll do is I'll use this feature called a fillet, and what this does is you click on 2 lines, and it basically turns them into like a curve. So, you know, let's do like, I don't know, 3 millimeter diameter curve. So I'll click on this and then this. Oh no, you know what? Actually, that's not good enough. Let's make it 7. That was more pronounced because you guys can't see it right now. So basically, what it's doing right now is it's actually making like this line and this line here. Instead of having that like change, it turns it into like a curve, and that's like a Fillip feature. There's another one called chamfer, and it does basically the same thing, but instead it actually creates like an angle like that. So what we'll do here is we'll repeat that Fillip feature over here, and then we'll repeat that Fillip feature over here. We'll repeat it over here. And then basically now you have something that looks a little bit more like a wrench, right? Like this is starting to turn into an actual wrench. And we first started with 2 circles and a line. Okay, so now this is a 2-dimensional drawing and we want a 3-dimensional part. So we move on from the 2-dimensional sketch to something called features, and here is where we actually add depth in using CAD. And it's the same thing for Inventor or AutoCAD. You'll hop from a 2-dimensional sketch to a 3-dimensional feature, but I think it's called something different on Autodesk. So now this is basically showing what happens when the wrench is 10 millimeters like in height. It's taking a 2D drawing and it's basically giving it height. We don't want a really bulky, 10 millimeter thick wrench. What we want is something more like a 5 millimeter a wrench with a height of 5 millimeters. So here we'll type in 5 millimeters. We'll click OK. Okay, now we're starting to get there. Okay, so the wrench, it looks really basic, but something I realized is that the ends of the wrench, where it's basically making contact with the nut, it's a little bit bulkier because most of the mechanical stress is happening there, so it needs to have a little bit more meat on it. So you know what? Let's basically let's add a little bit more depth on the ends. So what I'll do here is what I did was I basically clicked on the surface of this new 3-dimensional drawing that we created. I just clicked on one surface. And what I'm doing now is I'm treating that one surface as a plane. So that surface, I can draw on it now, like a sketch. So that's what I'm going to do now. I basically clicked on this, and now it's a plane. I'll just, create over here as well. And see what I'm doing right now. I'm just tracing the shapes that I did earlier using here, and then I'll just trace over here as well. Okay. Just trim this out. Okay. So I'm thinking of adding like maybe another 2 millimeters of height to these ends right here that you see. So they're going to be a little bit. They're going to have a little bit more height versus the core of the wrench. So I made it 2 millimeters in height. I clicked OK. I want to do the same thing on the other side of the wrench, but I'm kind of lazy and I don't have to draw that all over again. So what I'll do is I'll click on, it's over here, it's reference geometry, and I'm creating a plane. Sorry, sit down for a second. Okay, I'm creating a plane in between both the. If you don't get something, just tell me. Or if it's like you're getting lost. What I did right there was I want to copy these 2 features that I made on this surface. So what I did was I clicked on reference geometry, and I clicked on this side, and I clicked on the bottom side. And what that does is it creates a plane straight through the middle of what I'm making. So that plane you see right there, it's an imaginary plane that basically cuts my part in half. So once I have that plane that runs through half of my wrench, what I'll do is I'll click on the mirror feature. And once I click on the mirror feature, it's like, okay, what's the the center plane that you're using? So I'll click on that plane I just created, and then I'll just click on that, click on the part that I want, and bam. It just, it mirrored the features I did on this side, and it copied them to the other side. Okay, so now the wrench is starting to take shape. but it still looks a little bit ugly. Like wrenches usually don't have these sharp, you know, drop-offs right there. So I'm gonna use a three-dimensional fillet feature, which is basically, it's a fillet, but instead of it being in 2D, it's in 3D. So I click on this right here, bam. It's a fillet in 3D. I'll do the same thing on this side.
Nice.
Create another fillet here. And this is just really for cosmetics. I mean, yeah, it also it's better, like, it helps transfer the load easier. Like whenever you have a sharp angle on a part like this, that's basically a failure point, and you don't want that. You want it to be more smooth, like, oop, hold on. You want it to be more smooth like that. Okay, so there we go. We now have ourselves an okay wrench that you could probably find at the dollar store or something. I don't think you'd see that at Home Depot or, you know, Husky brand or something. But yeah, okay. So what we'll do now is we'll save it. We'll save it, and here we'll call it wrench. And I saved it as a Solidworks part. But whenever you want to export anything to a 3D printer, you want to have it in a file named STL. Like, you know, whenever you're exporting something, you want it in STL format. So I'll also save it as an STL file right here. SolidWorks allows you to...
Can you engrave something on that? And then
Oh, you know what? That's a great idea. I completely forgot about that. Okay, you know what? Let's write code RGB on this wrench. So you can even put your name if you wanted to, but let's... Code RGB. Okay, so now what I'll do is I'll put a straight line in between here. And the line that I'm putting right there is basically going to act like a line that you write over, like, you know, if you're signing it or something. We don't want to have code RGB up here. We wanted to have it like kind of like in the center. So what I'll do is I'll offset that line maybe, I don't know, like maybe 3 millimeters. So we don't want it bidirectional. Okay, so that's the line we're going to be writing on. So right here on sketch, there's text. What curve do you want to write on the text? We'll put it right here. And we'll write code RGB. Oh. Code RGB. We want it in the center. We actually want it a little bit bigger as well. So bold, maybe 14, let's see, 16 size. Yeah, that looks good. It's a good, decent size. Or you know what? Nah, actually, let's make it a little bit bigger. That way it's more centered. Make it a little bit bigger.
You can put 6 millimeters, can't you?
I could.
The center of the wrench.
Yeah, I could.
Units.
I could, but yeah, I just, you know, I made it really big. That way, you know, it's really prominent on the wrench that we're making right now. So there we go. I don't know why, but whenever I write something on SolidWorks, I usually have to delete the lines that I used originally. Otherwise, it won't let me extrude it. So now I deleted the 2 lines that I made. I click on regular extrude, and then bam, it's going to extrude it off the surface of that wrench. So I'm thinking 2 millimeters might. Let's make it 1.5 millimeters. Okay, so there we go. Code RGB, you know, on our wrench. So I'll save it again, and I'll save it again as STL file. So now it's saved as an STL file. Okay, what do we do next? What we do next is we open up Makerware. So Makerware, it's basically the software that comes with a 3D printer. It's completely free. And what I really like about MakerBot is they're constantly updating it. So this Makerware that we're using right now is a lot more sophisticated than the Makerware I was using 2 years ago. So what we'll do now is we'll add a file. We'll go to code RGB, we'll type in wrench, and then we'll move it to the platform. Okay, so this right here that you see right here, this box is basically the box inside the 3D printer where the build platform is. You can't have anything bigger than that box. So right now the wrench is like a lot smaller than the box, so we have nothing to worry about. But I've had instances where I'm really pushing the limit of that box. Like it won't fit like up to down. So what I'll have to do is I'll basically have to change the angle and like make it come from here to like over here just to get it to fit in there. And then sometimes if the part's really, really too big, what I'll do is I'll print it in 2 parts and then I'll just glue it together. That works out too. So okay, so what we'll do is we'll rotate this. Another thing that's really important, and I know it sounds weird, is that the bottom part of that's not visible. Okay. Something that that kind of bothers me is oftentimes, and I don't know if it's just my 3D printer. I think it's like a lot of 3D printers. You'll have to like tweak the part. Like I've had instances where I'll want to print a part like this, and whenever I print it, it'll keep on failing. Like it'll keep failing, and then I'll print it like this, and it'll print like a dream, or like and it happens a lot. Like it's kind of a little black art, like superstitious thing. Whenever you're working with a 3D printer, like I used to print in my garage, and my prints would always come out poorly, so I moved the printer into my room, and it started printing like a dream. And then another thing is the quality of plastic as well varies. Like this is like there's 2 types of nozzles that usually FDM printers come in. One is 1.75, I believe, and the other one is 3 millimeters. They're millimeters, and like this is supposed to be 1.75 millimeters in diameter, and this one's actually it's a pretty good like printer filament. Right here it's like 1.8, but the thing is, if it varies a lot, it'll jam your printer. And like there's like really cheap Chinese companies that sell you like filament, 1 kilogram of filament for like $3, and you're like, oh wow, I'm getting a great deal. You put it in your printer and like it kills your printer because like it's really like it'll vary from like 1.9 to like 1.6 into 1.5, all within like 1 spool of filament. So so that can break your 3D printer too, and then you have to like open it up and fix it and everything. So what I did right now is actually I changed the angle on What I did is I changed the angle of which the wrench was printing on. Instead of printing it flat, I'm printing it at a slight angle because when I print it flat, the bottom surface of the wrench, it comes out like in pretty lousy quality. Like it doesn't come out really great. So I realized that printing at an angle, like the quality increases slightly. So what do we do next? We click on settings. So yeah, settings. This is really important because it basically dictates like more or less the quality of print you want. MakerBot has 3 standard resolutions. Low resolution is basically, it has a thickness of about 1/3 of 1 millimeter, 0.3 millimeters per layer. High resolution is basically 0.1 millimeters per layer, and that means like just to go through 1 millimeter of height, it needs to print 10 layers to like make that distance. So for a low resolution print, which is at 0.3 millimeters, it would be something more like 3 layers. So I'm just gonna put like standard resolution right now. You can tweak it too. Like layer height, usually if I don't want to do just straight up high or low, I'll meet it in the middle and I'll do 0.15. Like you can modify that too. You can also modify the temperature it's printing at. The default temperature for PLA, which is the plastic that we're using, is 230. But if you use polycarbonate, which is a really high impact tolerant plastic, that's at 270. And that's like the upper limit of what the 3D printer can do. I've tried printing in polycarbonate before, but I can never get it to stick to the build plate. Like it'll flow through the nozzle, but like it'll begin to peel on the plate. You can also print with nylon. Nylon, I think it's 245. Like the different like materials you're using, the temperature the extruder is extruding at like varies. So right now we're just using the standard 230, which is with the PLA. I'll be completely honest with you, I never messed with the speed because I did it once and like, you know, I don't know what was going on. So like, you can modify that. That's basically the speed at which the printer is moving around, the extruder is moving around the printer. So everything looks good. I'm just gonna save this. I clicked on supports. Usually I don't like putting on a raft because it's a waste of plastic. But okay, so here we go. We'll click on print, and this is really cool. This wasn't on the Maker software 2 years ago. After you click on print, it'll tell you more or less the approximate print time. Here it says it's going to take about 25 minutes to do this. Something you might want to know is whenever you modify the resolution, a low resolution print will probably do it in half that time, like in about 15 minutes or 14 minutes or so. A high resolution print will probably be double that time. It'll probably take 40 or 50 minutes to do it. And like I mentioned before, it's because of the layer platform. For the print. Another thing it does here is it calculates more or less how much plastic you're going to use. And it says for the wrench we're going to use about 6 grams of plastic. And this is another thing that's really cool. If you click on print preview, you can actually see like more or less the machine code of like how the print should look. And you can even see the supports underneath, like, oh, hold on. There's support underneath the wrench for basically, like, you know, because let's say if you have like, let's say you're printing a part like this, the printer will start right here, and it'll keep going up, 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 up. But once it reaches here, if it tries to print something and there's nothing here, it's just gonna like extrude and the plastic's just gonna fall straight down. So what it'll do is it'll generate like actual support platforms right here. And it'll print this, and it'll print the top part. You take the piece off, you just break off the support, you throw the support away, you have yourself the part. So that's how it prints over like, you know. So what I'll do now is I'll click on start print. Like I mentioned earlier, usually this is not how you put your filament in here, but you know, I've been having issues, so I'm just... I've also done a little bit of modifications. Like this is a little bit over 2-year-old printer. I've added a heat sink on the back. A few of the wires came loose, so I basically had to tape it together with electric tape and use paper clips. It's like really... They don't kid around. They say it's like do-it-yourself 3D printing. Okay, so it's in. It's probably a bad angle, but. Okay, so now it's starting to print. Like for those of you who want to check it out. And once it reaches, it should tell you the temperature right here. Once it reaches 230 degrees centigrade, it's going to start printing. Usually what happens is this filament would come through the back and the spool would be over here. But like I mentioned earlier, I've been having problems because like the drive gear for my MakerBot, like it seems to be jamming or something. So there you go.
What's the price on something like that?
This one, when I bought it, was $2,200, but I think the price has come down to like about $1,800. You can buy a Chinese copy of this for I think $1,000. There's smaller 3D printers that cost you about $300. There's bigger 3D printers that cost like $5,000. And yeah, so that's the first layer. You just print the first layer.
What about the printers? Because I've read that you can print your own parts.
You can. A lot of the early 3D printers had open source designs, so you could get a 3D printer and you could print like parts to make a new 3D printer. You still have to buy the electronics.
Yeah.
So don't think like
They run
printing.
on like Arduino board.
Yeah, like this runs on I think on Arduino Uno, and it uses a standard NEMA stepper motors. So yeah. This is gonna take a while. So if everyone wants to go out and get some pizza, we can come back later and see how it goes. We actually did when I was taking materials, we did a bunch of like engineering tests on 3D printed supplies, and we basically we did like like we don't want to spend a lot of plastics, so we do 10% info and like maybe 2 layers. Yeah, of course. Hopefully it comes out okay. Yeah, okay. Just need to make sure it's still going. Yeah, it's still going.